So in this lecture, we're going to be looking at what are called improper integrals of type 1, or of the first type. These are ones where the range that you're integrating over isn't finite. There's going to be an infinity in the range somewhere. And there's three different ways that this can happen. All right. One is where the upper limit is infinity. The other is where the bottom limit is negative infinity. And the other is where both of the limits are infinity. We're really essentially are going to handle all of these the same way, although the third one gets a little interesting. What we're going to do is just replace the infinity with a variable, right? A real number, a real valued variable, something that we could substitute into the antiderivative, just like we've always done with indefinite integrals. And then we're going to take the limit as that variable goes to infinity. Right, so if it's positive infinity, we'll replace the upper limit with that new variable. If it's negative infinity, lower limit gets replaced with the variable in the limit. And if we're doing both, right, if the upper and lower bounds are each negative infinity and positive infinity respectively, then all we're going to do is we're going to split the integral into two parts at some point in the middle. Doesn't matter what that point is, and you'll see as we get into some example. Pick a point that makes the substitution into the antiderivative easy, right? So essentially, we're going to pick a c, any real number, and we're going to split the we're going to split the integral, negative infinity up to c, and we're going to treat that like case 2, c up to positive infinity, or we're going to treat that like case 1. All right, so let's see how we can do this. We're going to do the integral from 0 to infinity of e to the negative x dx. Well, first, make that replacement. Right, I'm going to replace infinity with b, and I'm going to put the limit as b approaches infinity out in front. Okay, so I know what the antiderivative here is. This is the limit as b approaches infinity of negative e to the negative x from 0 to b. And if we put those two limits into here, this is negative e to the negative b minus negative e to the negative 0. All right, this part here, that's just 1. So this is the limit b approaches infinity, negative e to the negative b plus 1. Now we can do the limit. The limit of this negative e to the negative b, that's going to be 0. The limit of 1 as b approaches infinity is 1. And that gives us our final answer. Right? That integral is equal to 1. All right, so how about this one? Right here we have that third case where we're going from negative infinity to plus infinity. So I have to split this up. And to see where I'm going to split this up, I'm looking ahead. Right? I'm looking ahead to what the antiderivative is and picking a number that I can evaluate that antiderivative at. So the antiderivative of 1 plus x squared is the arctangent, or the inverse tangent. So what I'm going to do is I'm going to split this up. I'm going to split this into negative infinity to 0 because I know what the arctangent of 0 is. Right? It's 0. I'm picking a number that's going to make my life easy down the road of 1 over 1 plus x squared dx. Oops, excuse me. Well, no, let's do it this way. Plus the integral from 0 to infinity of 1 over 1 plus x squared dx. Now I'll replace these with limits. This is the limit b approaches negative infinity, the integral from b to 0 of 1 over 1 plus x squared dx. Plus, you really need to pick another variable here. So we'll make this the limit as a approaches positive infinity, the integral from 0 to a of 1 over 1 plus x squared dx. And now we'll do the integral part, right? We'll get the antiderivatives in there. So this is the limit b approaches negative infinity, inverse tangent of x from b to 0, plus the limit as a approaches infinity of the inverse tangent of x from 0 to a. And so now what do we get? We're getting there. This is the limit b approaches negative infinity, inverse tangent of 0 plus the inverse tangent of b, plus the limit as a goes to infinity of the inverse tangent of a minus, whoa, this should be a minus here. I'm sure you all caught that, right? That's minus inverse tangent of b minus inverse tangent of 0. Okay, the arctangent of 0 is 0, right? So these just kind of go away, right? And what are we left with? We're left with the limit as b approaches negative infinity of negative inverse tangent of b plus the limit as a goes to positive infinity of the inverse tangent of a. Okay, the left hand one. As b goes to negative infinity, the inverse tangent function goes to negative pi over 2. Right, so remember the tangent of negative pi over 2 is, well, it's not really, it goes to negative infinity. It's dropping off to negative infinity on that side. So this is going to be negative pi over 2 plus, and the same thing is going to happen over here. The limit as a goes to infinity of the inverse tangent of a is positive pi over 2. The negative signs cancel over here, and our final answer is that this integral is equal to pi. Okay, so that's how we're going to handle improper integrals of type 1. So in the next lecture, we're going to go ahead and we're going to take the next step, and we're going to look at how you do improper integrals of type 2.